Okay, this question is homework 2, number 1, and it says figure example 21.1 is a snapshot graph at t equals 0 seconds of two waves approaching each other at 1 meter per second. Draw 6 snapshot graphs stacked vertically, showing the string at 1 second intervals from t equals 1 second to t equals 6 seconds. So this is the graph that they give you. And so we see that the waves are moving at 1 meter per second, and this is the graph at t equals 0 seconds. So when you start the next graph, you're basically going to move each point on the graph 1 meter over. So at t equals 1 second, you move the positive wave 1 meter over. So we started at 0, so now we're here at 1. And then we had our amplitude start at 2, so now here it's over at 3. And then it goes up to the amplitude of 1. And then it started at 4, and then it moved over to 5. And then for the negative wave, same thing. It moves over to the left 1, and it started at 10, so now it's at 9. And then it started at 8, and now it's at 7. And then here it started at 6, so now it's at 5. And here is the line that you get from the resulting graph of the two waves that are touching at 5. And then when you go down to t equals 2 seconds, you see it moves again 1 meter over, either to the right, the positive wave moves to the right, and the negative wave moves to the left 1 meter. And then if you were to look at the point x is equal to 5, and you look at the y values, they are equal but opposite. So you see that they would cancel each other out since the amplitudes are equal but opposite. So that results in an amplitude of 0, meaning that this value at 5, you get a line right here for the graph. Okay, and so then now we're going to move up to here at t equals 3 seconds. So again, if you look at this graph, it's going to move over 1 meter to the right and left. So it moved to the right t equals 3 seconds. At t equals 3 seconds, it moved to the right 1 meter and to the left 1 meter. So now you see that you get a snapshot of the graph here. The waves cancel each other out because the two positive and negative graphs, or positive and negative waves, are on top of each other. And so this is superposition because the two waves are equal but opposite, so that results in complete cancellation of the graph, of the wave. So then you look here, same thing, like at t equals 2 seconds, you have the same thing where the negative graph moves to the left 1 meter each point, and then the positive graph moves to the right 1 meter. And then you see the resulting graph would be with a point going through 5, x is equal 5. And that's because if you look here, the amplitudes are opposite but equal. So then the resulting would be a 0 amplitude. So then that amplitude creates this line right here. And then you go down to t equals 5 seconds, and it's the same thing like at t equals 1 second, right here. The graphs are moved over 1 meter, and you have the waves are moving to the right and the left, and then you get this resulting graph showing that they are touching each other at that one point at x is equal to 5. And then for x is equal to t equals to 6 seconds, the waves have now shifted over completely. So the positive graph is starting at 6, and then it has an amplitude of 1 at x equals 8 meters, and then another point at x equals 10 meters, and then same for the negative graph you have a point at 0, and then another point at x is equal to 2, and then the amplitude at -1, and then x is equal to 4. So these graphs have completely moved to the right and left at 1 meter per second. And this is showing deconstructive interference because you have one positive wave, which is up here, and one negative wave. And that's how you would do this problem.